Come on later.
So, welcome everyone to the new year, the 2025. Seems like it didn't take that long last year. This is the first meeting of the month of the year for the Astronomy Fundamentals group for Tucson Amateur Astronomy, and I see a lot of names that I recognize. I'm not quite sure if we have any new members tonight in the group. Maybe two. So welcome. For those who are joining us for the first time, this meeting typically has two parts. We have it consists of generally of two presentations. One is been focused more on a notable astronomer and some of their achievements and discoveries, and then a second presentation which is on a more broad topic. Which for tonight I will be giving the astronomer presentation on Walter Baade. And Stephen will be giving the presentation on electronic assisted astronomy. Stephen, if I
Smart scopes.
smart
Oops,
scopes.
sorry.
No,
Sorry, I
okay.
did the wrong button.
So let's double check. Is everyone able to see my screen? Any thumbs up if you can? Cool. Thank you very much. And so with that, um, this meeting might not be very long tonight, despite um, Walter Walter Bade's notable achievements. There's surprisingly little information that I could find on him that was at least more that wasn't very superficial and high level. So Walter Bade was a German astronomer who was born at the tail end of the 19th century. He was born in 1893 outside of a place called West in the Westphalia province of Germany. Two Protestant parents. Well, his father's name was Conrad. That is a typo on my part. I did not catch that. Who was a school teacher for uh, the one of the local schools. I'm not quite sure if it was what level of school, if it was primary or high school. And he had a mother who was what seems to be mostly a stay-at-home mother, and could not find any information on whether or not he had any siblings. His parents wanted to have him pursue theology as a background early in his life. They sent him to school hoping that he would pursue that. Instead, he took a 180 and went down the path of mathematics and astronomy in primary school, where he fell in love with the topics there. He attended a little small local school called Hereford at Hereford, Germany. And Uh, this by the time he was getting into his late out of his teens and graduating high school and going into college, World War I happened. But fortunately for him, he was able to escape military service due to a hip defect. So my understanding is that he had it would have prevented him from doing a lot of the stressful physical activities that would have expected of soldiers. And so he was able to skip out of that, miss that conflict entirely, and mostly focus on his studies in Germany. So for his university, he attended the University of Nottington, if I am pronouncing that correctly, and I assume I'm not because my German is terrible, starting in 1913, where he didn't stay very long. He transferring out of that university. Oh, sorry. There was another university before this. I forgot to write it down here. But he transferred into Nottington in 1913. There was another university he attended briefly before for about 6 months, where he would stay at Nottington throughout the rest of his academic career before earning his PhD in 1919. His academic advisor was Professor Felix Klein, who I'm not quite familiar with. But regardless, Bade's presentation was on the spectrum of the double star Beta Lyrae, which from what you would normally associate with beta stars, you wouldn't think there would be enough to write a PhD dissertation on the star spectrum, of the spectrum of an individual star system. Nonetheless, that's what it was. And after earning his PhD, he was invited to join the University of Hamburg's observatory staff, where he would spend a brief amount of time. This particular observatory was notable for being home to the largest reflecting telescope in Germany at the time, just a very large 1 meter reflector, which by some of the other standards, even some of the scopes that we have here in the club, is surprisingly small for a professional scope. He stayed at the university for about 10 years or so, and was in line to actually become the observatory's next director in 1929, but he declined, and we'll go into why he declined that opportunity here in a moment. But what some of the main things, the main thing that he was responsible for of note during his time at the Hamburg Observatory was mostly for the 1929 solar eclipse expedition that the university took to the Philippines. Mostly spent a lot of his time dabbling in, or being forced to dabble in to lesser areas, mostly comets and, excuse me, sorry about that, and something in my throat. Dabbling in asteroid orbits and comets, which today are of note, especially for asteroid and collision detections with Earth. But in the early half of the 20th century, was mostly some rote backwater, like desk jockey sort of work, and not the kind of things that he was overall interested in. Despite this and the expedition, he would go on to discover what is the asteroid 944 Hidalgo. So for those who aren't familiar with how asteroids sometimes get numbered, the number in front of them denotes their relative size in the asteroid belt. So in this case, 944 says it's the 944th largest asteroid that we have found. And it was named after uh, a Mexican revolutionary who helped Mexico declare their independence from Spain with the permission of the Spanish government, is where this name comes from. And also discovered 10 other asteroids. This is of note because this was what is now known as a centaur, which are a unique class of rocky bodies that lie in the outer solar system. Mostly, they're not chemically distinct from asteroids. What separates them is their unique orbits. And as I said, all of these lie in the outer solar system, but their unique characteristic is they mostly stay there, but they cross through the orbits of one or more of the gas giants. This makes their orbits very unstable and, in astronomical terms, very short-lived, although not short-lived on human timescales. And most of these bodies will either become comets that are flung in towards the sun and will disintegrate, or they will be flung out and ejected from the solar system into interstellar space. There are quite a few of these objects that we have managed to find. Centaurs weren't formally cataloged as a separate class of object until 1977. But since then, we've managed to isolate quite a few. This is a rough chart trying to show what orbit planes some of these objects intersect, which is this red line here. So this object up here, 2005 RO43, it intersects the orbits. Its orbit takes it through the orbit of Uranus and Neptune, and possibly out past Pluto, which is not shown here on this chart. And the size given by the size of the object given by the dot and how inclined it is to the plane of the solar system given by the angle here. So as you can see, there's quite a few of them. And where is Hidalgo is actually not on this chart. But there's some others that we may recognize. So as we saw, as I mentioned briefly, he declined the role for a directorship position. This was because in 1926, he was invited as part of a grant from the Rockefeller Foundation here in the US to do a sabbatical year where he visited many of the larger universities and observatories here in the US and ultimately made his way for a 6 month stay at Mount Wilson during this time. And when he got back to Germany, he did some I don't like this scope, and like many of us, he left Hamburg for the search of bigger aperture telescopes was the primary reason. And so in 1931, he left Germany with his wife after accepting a position at Mount Wilson Observatory, where he would stay until 1958. This timing was also fortuitous with the rise of Hitler and Nazi Germany, but it's not quite clear from what I was able to find if that was another one of his decisions for leaving or if it just happened to coincide. It's not really clear on that. And at some point after arriving in the U.S., doing a couple of years, he at some point lost his paperwork for moving into U.S. citizenship. He did not really like bureaucracy, and so he never bothered to apply for a replacement. Much to his dismay and some of his colleagues, this resulted in him being classified as an enemy alien in 1941, where he was forced into house arrest in LA, and he could not actually leave out at night, which, as an astronomer who needs to go up to an observatory to go look at things, was a huge impediment to his work. Despite this, and some of his colleagues were able to persuade the local the immigration authorities to allow him to stay on Mount Wilson during the night in order to accomplish his professional duties, which basically confined him to Mount Wilson as well. This actually was a really big boon to him in his professional work. His enemy alien statuses prevented him from working on a lot of other projects that many of his colleagues at Mount Wilson were turning towards as World War II was kicking into high gear, which basically gave him free reign of the observatory's largest telescopes. They were all his other colleagues were happy to do other things. In addition to this, the wartime blackouts that were forced on LA in order to prevent coastal shipping from potential Japanese submarine attacks made it so that he could turn the largest telescopes over into targets that you would not be able to because of the light pollution in the area. This allowed him to discover several things. The first being what's known as now actually a region of space that bears his name, known as the Baade window, which is a region of sky between NGC 6522 and 6528, which is a deep seeing window past a lot of the dust and gas and the armbands that rest on the band of the Milky Way. So it's essentially a pothole in the dust bands, which allows us to see farther into the galactic core than other areas of the night sky. And this is still a region that's actively used today because of these characteristics. There's a few others as well, but this was one of but the Baade window was one of the first ones found. The next thing that he helped discover during this time was the discovery of what we now know as population 1 and population. Oh, nope. Next slide. I'm jumping ahead of myself here. The light pollution that was turned off because of the blackouts in LA allowed him to observe deeper into the core of the Andromeda Nebula, it was still a nebula at the time, It hadn't been, no, sorry, this would have been after Hubble's work. So it would have been starting to gain traction as an independent galaxy. And so he was able to use these black hole conditions to discover that there are not one, but two different types of Cepheid variable stars. This is notable if you've been with us on some of our other topics. Cepheid variables are very important in helping to determine nearby distances within the universe. And so the discovery that there are not one or two different, there was not one type, allowed him to recalibrate what we now know, what was in some of the earliest distant measurements for the size of the universe that was first positioned by Hubble in some of his landmark work. This allowed him to correct an error in Hubble's work, saying, hey, the universe was this young, which can, as we may recall from the last time I talked about Hubble, that Hubble's work initially said that the universe was younger than some of the planets in our own solar system. So this discovery of multiple Cepheid types allowed Baade to correct for that error and helped gain a lot more power and traction behind the still building Big Bang theory. But he wouldn't actually announce this discovery until after World War II at the first post-war meeting of the International Astronomical Union in Rome in 1952. After that, he, well, slightly before the blackouts and World War II, he joined up with a colleague at Mount Wilson, astronomer Fritz Zwicky, who is an interesting person who we haven't actually presented on, and we need to because he does a lot of really cool things. But together, Baade and Zwicky
Connor, we lost your audio. He says, one moment.
Mike, you guys hear me?
I can barely hear you.
How about now?
There we go.
Okay. My headset decided to power off for 1 second. Let me resume this recording. Sorry about that. I had a headset issue. My headset RAM decided to turn off. Uh, so uh, joining up with Fritz Zwicky, the pair just published two papers in 1934, which just coined two terms which we still use today. They first posited the existence of supernova as well as neutron stars. And namely, what these two papers are very important for, was they outline the process, how neutron stars are actually formed. They correctly stated that supernova are created from the explosion remnants of a supernova. Although they didn't get the physics quite right, because at this time, we didn't understand that stars were powered by nuclear fusion. And he also correctly posited that supernova are one source of high energy cosmic rays. So very important things that we still recognize today. But interestingly enough, supernovas were quick to actually gain traction within the larger astronomer community. But neutron stars wouldn't actually really go anywhere until we detected our first pulsar in 1967. Come on, next slide. I feel like I'm missing something here. Did I miss something? Um, oh, I missed an entire slide here. So one thing that I thought I put into this deck, but didn't make it or got lost when I hit save. He is also important for, and part of his work for Andromeda when he was reestablishing, when he was observing these new types of Cepheid variables, is he also discovered what we now know as population one and population two stars. These are a shorthand in astronomer terms for outlining how young or how metal rich or metal poor a given star is. Uh, which is basically how we can determine how early in the universe that star formed as one simple way. For example, population one stars are young stars. They are very metal rich, which in astronomy terms means anything except hydrogen or helium, which we now know as part of the process in which heavy elements form. So these stars were built after the dust and remnants of many other exploding stars, while population two stars were metal poor stars, lacking some of the many of these heavier elements. And then the population three stars, which he did not hypothesize at this time, but we still think that they exist. We have not detected any of these either. Are some of the earliest stars in the universe that contained no heavy elements or very trace amounts of heavy elements, because they wouldn't have time to gather them from other supernovas. So very big and major discoveries that he's made that have been very important overall to larger astronomy. And despite this, he, after this very long career at Mount Wilson, he retired in 1958 and briefly became a lecturing professor at Harvard for a short time before he and his wife would move back to Germany in 1959. Unfortunately, his retirement did not last long, and he died in 1960 due to surgical complications from a hip surgery. And some relevant references for those who might be interested. I'm coming back later in this recording. Any questions or comments on Walter Baade before we move on to Stephen? Okay. Stop the share there. Stephen, whenever you are ready.
All right, you ready to share screens? Where is that? It's over here. And there we go. See my screen? Yes, you are. And there's this. Okay, so this was put together relatively quickly. So it's not quite as pretty as Connor's, but I am going to just go over a brief summary of smart telescopes. Are they the future of amateur astronomy? And I'm going to hit the, hopefully, if I can get that to go away. Thank you. Slideshow and go like that. All right. First of all, I need to preface this. I do not have a smart scope yet. So I've ordered an S30 C Star, and it is still being delivered to the United States from wherever it's coming from, and it may be a few more weeks before I get it. I have played with a few of these things and seen a lot of them recently. So if there are people a little bit more familiar with these things than I am, then I make a mistake, by all means, chip in. The other point is that this is not so much about how to use one. I may come back in a few months when I have had a chance to learn how to use one and talk about that. So much as just give an overview of what they're all about and ask the basic question is, are these things really as big a deal as they seem to be right at this second? There are new technology. The basic elements have been around for a little while, not too long, but various companies kind of merged a bunch of automated software and hardware in the last couple years, two or three, to make what we call smart scopes. And what is a smart scope? There isn't really a definition, but for the most part, they are highly automated entry-level equipment that orients itself, finds targets, images the object, and then delivers the image to a phone or tablet with minimal input from the user. Another thing I forgot to mention is they are almost always controlled by phone or by a tablet, there's very few that actually have a hand paddle anymore, and they also show their images that way. So that's a little bit different from the older Go 2 scopes, which are, at least for many years, were driven by paddles, although the most modern versions are generally also compatible or exclusively compatible with a phone or a tablet. They are currently designed for users with minimum experience with telescopes. That does not mean they are all entry level priced. Some of them are actually still quite expensive. Some of them are actually very affordable. And we'll talk a little bit about some of the reasons why that might be a little bit later in the presentation. But the reality is that a lot of experienced users, including a lot of club members, are buying them for various reasons because of their ease of use and because they have a way of sort of providing a new way to interact with the public. And I'll talk a little bit about that again a little bit later on in the presentation. So this is just some of the simple pros to the Smart Scope. They are, for the most part, fairly easy to use. You can learn how to use them in a night or two, depending on what particular software or unit you're using. Again, depending on what you want to use it for. They don't have a steep learning curve at first, but there is a little bit of a learning curve. I'm sure if you want to use some of the more advanced functions, if they exist, that takes more time. Obviously, this isn't something where, as I joke, it can't yet wheel itself out of the living room yet and plant itself on the porch or the patio to take pictures. They are also fairly functional. I'm amazed what some of these little things can do. Given the fact that they are tend to be small optics and not necessarily the highest end imaging chips, although they do actually use pretty sophisticated ones in what they're able to do. They know the other advantage of this is they allow a new user to jump into astrophotography with very little experience in astronomy. This is important because a lot of interest right now in astronomy is in astrophotography, and there are reasons for that. Given that people tend to be leaning more into their phones and into their tablets and into their screens to kind of live their lives, it makes sense at this point that this would be a moment where people will be more comfortable than with this than they might have been 20 years ago. They produce a cool picture quickly that is easily accessible. That doesn't mean it's top end astrophotography, but it is something you can show people on your phone and possibly send in an email or post on social media or the like. It is a pretty good image, not perfect, but pretty good. It does the process of taking an image and processing it almost entirely automatically and within just a matter of minutes. That is something that is very different from traditional astrophotography, where both the taking the pictures and then most importantly the post processing is a very involved, very involved process in some cases, where it takes a lot of time to produce the image. Sometimes weeks go into making an image, whereas this can do it in just a few minutes. Again, this is the images you get are good. They're not perfect, but they are pretty good. And it's very exciting, I think, for the digital generations who basically live on their screens, as some people under a certain age tend to do. The cons, there is in fact a small learning curve. As I said, these things can't quite put themselves out into the backyard and turn themselves on and go take pictures for you. There is a process that takes a couple of days probably to learn how to do the processing under a night sky. It's not instantaneous. Some of the software isn't completely intuitive, so it's not completely mindless. The other thing is that most of these telescopes right now are small optics, so they're really geared towards an entry level person or a moderate level person. Not there as of yet. I'm unaware of any 14-inch smart scopes, although some 14-inch smart scopes can be. You can add a lot of things that can do what a smart scope can do, and probably better, but they're not packaged as that. The cameras are sensitive, but don't necessarily have the best or the largest or highest pixel density of any chips that are out there. And I say the processing is adequate. meaning that it produces a pretty good image for a little scope. In fact, probably better than I would ever expect, considering the fact that some of these are 50 millimeter optics. But it lacks the finesse of doing it yourself. You can't tweak the image straight off the bat in quite the same way as you do if you want to spend, say, 6 weeks building up an image. And it completely or mostly completely removes the user from learning the art of astrophotography. Now, some of the new ones do allow you to download the RAWs, and if you want to spend the 6 weeks processing all of that, you can do that. But it's not necessarily something that a new user would want to do. The other disadvantage I've seen with most of these is that they are on alt-as mounts, altitude azimuth mounts, which means that they can't really do long exposure photography. If you consider that important, that could be a major drawback. If you're okay with the software being able to compensate for most of the image rotation, it can give you anywhere from 10 to 30-second tops exposures, and it uses additive imaging to create the exposures. Not again, not perfect, but I'm amazed what these images look like given the fact that they're tracking an object over several minutes and building up a fairly good image in a relatively quick period of time using what are, for astronomical purposes, are essentially snapshots. So pretty cool technology. So uses for beginners are kind of obvious. These are being marketed to people who don't have a lot of experience with astronomy. Again, a lot of us who are experienced are picking them up anyway and using them for a lot of different things. But the reality is that for decades, amateur astronomers and indeed professionals spent years learning how to do photography, while most photographers who coming into astrophotography spent years learning how to do astronomy. Now you can come at it from either direction almost overnight. In some cases, if you're good at picking up the software, you can do it overnight, and so it's greatly sped up the ability to transition to astronomy or astrophotography, depending on which way you come out of it. It's a great tool for drawing in a generation of users who are high on digital nativeness and low on attention span. So basically, everyone under 40. Sorry, Connor, but I work with a lot of young people, and they're very good with sitting on a computer and the like, and they're wonderful people. But the attention span, it seems to be a little bit decreasing over human history. But I think that's something every older person has always said. That said, it is something where for a generation that's not big on spending years and years and years learning a process, this is great because you can jump into it without having to do that. Some are actually very affordable, and there's a dark side to that, which we'll talk about in a few minutes. The CSAR S30 is currently being sold for about $340, which is better than a lot of Dobbs are currently being sold for. And some are high-end prices, $5,000 or $6,000. If you want a high-end one, they can be very pricey. I haven't seen a lot in the middle. There is one that's sort of in the middle that I'll talk about in a minute, but it's for the most part you can either go super cheap or super expensive, but they tend to, at least in principle, be the same basic concept. It just depends on what kind of quality you're looking for. They are also tend to be very small, very portable, very easily set up and used. They're a great way to get started if you just want to take a few pictures a few nights of the year and show your friends and the like, and you don't want to get that far in the hobby. But we would hope that some of those people really would get into the hobby once they get the bug for it. So the other thing I would say, and I've talked to a lot of people about this over various time frames and various arguments about this, but I tend to think that the last statement is sort of true. I think for a lot of us, photography is the way the hobby is slowly moving. That doesn't mean visual is going to go away. But I do think that especially for newer generations coming into this, there's more of an interest in seeing what you're seeing from the internet than there is necessarily looking at faint fuzzies. Now, that's not to say that people won't do that and that that's not enjoyable. It just means that I think, again, especially depending on the generation, there is a tendency to connect a little bit more with pretty pictures than there might have been 20 or 30 years ago. And I tend to think, given the way society and technology is going, that is a trend that will continue. So Not again, none of this is saying that visual astronomy is going to go away. None of this is going to say that we're going to be exclusively out there with digital pictures in 20 years now doing outreach. But I do think for a lot of people coming into the hobby, there's more interest in jumping straight into photography than there was originally, probably because it's become so easy. Um, Uses for advanced users, and this is what a lot of us are doing with these scopes, even though we've spent years and years with other types of telescopes, is outreach. Again, if like I've talked to a lot of people, the plan is to have a visual scope on one side and a digital scope on the other, a smart scope on the other, or just do the digital scope, or maybe some nights bring out the old knob and some nights bring out the smart scope. So it has a real potential there to sort of connect with the public, especially younger users who might be confused by what they're seeing in an eyepiece. Again, we're not going to get rid of the visual scopes, but it is a good add-on. Grab and go is an option, especially for the small ones. They're fairly easy to move around and set up. They don't weigh 150 pounds. The limitation with that, of course, is that they don't weigh 150 pounds. You don't get the big optics. But they can do a lot for a small scope. You can take it camping. You could potentially take it with you on a vacation. I'm not sure how well it would hold up on an airplane, but I'm sure people have tried or soon will try. You can take it almost anywhere, including under moderate to somewhat significant light pollution environments, because the software does a fairly good job of cutting through that. It's not perfect again. That is probably going to be something that is going to become more and more interesting over the next 20 years is how do the software solutions deal with things like light pollution and satellites and Starlink and all the rest of it. The things are changing a lot for amateurs, but the technology is racing to keep up, and maybe it'll stay ahead. We don't know. You can use it with the kids. Again, kids are happy with bright, pretty pictures. Sometimes a little bit disappointed with things other than the moon and the planets when they look through them through the scopes. Or a little surprised by it. This can be for people who've only seen pictures, be a good way to get them started. I think there's still merit in showing what these things actually look like through the telescope, but that's just personally me. But yeah, some would agree and some would disagree. You can use it when you don't want to spend hours setting up and taking down equipment. The reality is that astrophotography equipment is big and cumbersome and expensive, and some of these are expensive, but it takes a lot of time to put these things together, get them calibrated, get them properly focused and the like. And these things do take a little bit of time to focus, but it is the kind of thing where you're going to save yourself a lot of time if you're not looking necessarily for the very best of images. So how they work over on the right, this is the Dwarf 3 Smart Scope. Basically, you have the, again, depending on what scope you're using, it is either a reflector or refractor of various types. Either the little dwarf star has a little opening or aperture lens at the front. I've only seen one of these in action. It looks like the head of a robot or a Mars rover, probably in the broadest sense, similar concept. Behind that, you have a mirror which goes to a series of lenses, as in a 5 or 6 element refractor, and then at the back of that, you have your chip which collects the image. And of course, some of those parts can move slightly to photograph. I'm not an engineer, and I haven't taken one of these things apart. They're a little bit pricey to do that with, so I don't know the exact details, but it is self-focusing to within certain parameters. You don't have to tweak anything on the outside. You do that with your phone or controller. This is the one that's better known, which is the C Star 50. In this case, you have a triplet lens. It is an apochromatic, at least in principle. And then you have two mirrors in the back, which then bounce the image forward onto and I believe it is a CMOS chip in both these cases, which is placed below the main objective. So this is a bent refractor of a type. Um, I almost refer to these things as devices rather than telescopes, because they're half camera, half optics, but they are rigged obviously for deep sky and astronomical images. But calling them a telescope may be a little bit of a stretch. So you have a growing list of options with smart scopes. It used to be that Unistellar was pretty much out there, and then everybody realized, wow, this thing has a lot of potential. It's selling really well. We need to get in on ourselves. So this is sort of the low end beginner. If you don't want to spend a ton of money, option. This is the one that I have seen a lot of. It is the C Star 50 S50. It is out and available. It is a very cute little scope. It is able to do a heck of a lot more than I ever thought the scope that size and dimensionality would ever be able to do. I'm not necessarily telling you to go buy one this instant, but it is something that is definitely out there. It has a 50 millimeter triplet lens. I don't know much about the chip. My impression is that it's good, but not necessarily the very top of the line. Obviously, for the price you're getting at, you can't, the top of the line chips are going to go more than that telescope goes for by far. It goes for about $400 to $500, which we used to be the price of a Dob. So it does a lot, and it's pretty entry level price and capabilities. It is controlled from a smartphone. I think you can control it from a tablet as well. And the interface is pretty usable. I've talked to people who've used these things, and it takes a couple nights to figure it out. How the software works, I may report back on in a few months when I've had a chance to play with it, but it basically uses modern techniques. I believe there's a focusing process that goes with it, and then it uses it's not frame dragging, it's basically takes a picture of a couple pictures of the night sky, matches up to its own internal maps, and that's how it orients itself. I'm drawing a blank on the actual term, but I'm sure you guys all know what I'm talking about. Um, this is the latest version, and this is the one that I have bought and I'm still waiting for. This is the S30, also by ZWO C Stars. This only has a 30 millimeter aperture, which is smaller than a lot of little DSLR lenses, but it's supposed to be very popular. It's only a doublet, so we're going to have a little bit of color aberration in there. But the reason I got it is that it is super portable. So uh, well, it's bigger than a cell phone, in terms of overall volume, but it's not a very big thing. You can put it on a tabletop and let it go do its thing. And I will report back on that maybe in a few months, and maybe have a couple other report on theirs. But it's along the same basic principles as the S50, just a little bit smaller. It supposedly has zoom function. I don't know how well that's actually going to work, but we're going to find out. This is the Dwarf Star 3. I've seen a couple of these. This is the one I was showing you the insides of. Again, there's an aperture or lens up at the front, and then it bends the image to the side and through those additional lenses onto a chip. I think it looks like the head of a Mars rover. It comes just essentially with the little camera, which is able to rotate up and down and to a certain degree right and left, I believe. Most people put it on top of a camera tripod, and it works just like the Sea Star. It just looks a little bit different in terms of how they have the optics oriented. Again, very compact. It's probably less than a foot across, a few inches up and down. It's not tiny, but it is very portable, very easily used. And I've seen some really good pictures come off of these on a screen. They're also very good optical and digital picture qualities. So another good option. I believe they're a little bit more pricey than a Sea Star. They're not exorbitantly expensive, but I think it's a little bit more expensive than the Sea Stars are. This is the original, or one of the original smart scopes. It was the Unistellar. Made a line of very good quality, high price, high end units. Again, probably targeting more towards a newer user market. One advantage that these have, or disadvantages, I've had some arguments with some of the people here about this, is that there's that little thing that sticks out of the side there, and that is what they're calling a lens. But there's a huge catch. It's actually looking onto a screen, a little screen on the inside that produces an image that, of course, it builds up as the telescope takes the picture. Now, you can also download the image onto a phone or a tablet or a computer, et cetera, et cetera. it can be a little bit confusing for people to not maybe necessarily realize that when they look in the eyepiece, they're actually looking at an image that is digital being built up over time rather than um, uh, something that is actually coming directly through the optics and into your eye. It produces a really nice image through that, and again, you can download it onto a screen or a tablet or a phone, and it does the same thing. But it's a nice imager. Again, fairly small optics. I think it's 3.5 to 4 inches. But like all the other things we've seen here, it builds up an image pretty quickly, and it's um, very portable. I would assume fairly easy to set up. I haven't been through the startup sequence with that one, but it is something where if you're looking for something that's a little more high end, a little more original, et cetera, then this is something that is a good option too. Um, and then there's also this one, which is a slightly different variant of the same basic principle. Unlike the previous two that we looked at, these are reflectors. So they're using basically mirror scope to be able to produce the image, whereas the Sea Star and the dwarf basically use lenses. So it's the difference between a refractor and a reflector. They have from I've seen fairly good correction. So obviously there is not just a raw um, uh, uh, um, Newtonian, but it is mostly using mirrors as its primary collector face, if I'm not mistaken. This is another variant that I found out there. I don't know much about this one. Is the Visferis 2 Smart Scope, another company that's in there? I believe this is another lens-based system, essentially a refractor with a camera at the back. I didn't note the price on there. I would assume it's somewhere intermediate between the Unistellar and the ZWO. I haven't seen this one in action, so it was kind of a surprise that this was out there. But I would assume if it's available and people have comments, we can talk about that later. And then this is, of course, the classic company getting in on the action. I think this is a really cool scope. It's a little pricey for me, but it's basically a number of Celestron technologies all lumped together into a smart scope. So you're looking at an SE next generation mount with a 6 inch. Um, I'm drawing a blank on it. It's the version that has the camera at the front. I'm very tired. I don't remember the exact term, but it's basically a modified Cassegrain, but it comes to a prime focus rather than, or Schmidt, right? It comes to a prime focus rather than a Cassegrain focus. But the camera's up on the front inside that, what functions also as a dew shield or housing or stray light protector, and basically, yeah, and the whole unit is able to function as a smart scope. I haven't seen this one yet. I would assume being Celestron with all those different parts to put together, it's got a lot of options. It is, I think, the largest aperture that we're looking at so far. But it is on the pricey end. It's about 3,000, 3,500, as they are quoting it. So if you're looking for something that may be a little more advanced than a C Star, but still classified as a smart scope with a lot of automated capabilities, this can be a good thing to look at. Certainly, if I had the funding for it, I would seriously think about this one. It might be a little less portable than some of the others. It's a little bit bigger, probably a little bit more of a thing to set up. But certainly, this is a 6 inch aperture. It's not horrendously heavy. Okay, so a couple controversies around these things, and I have to phrase this very carefully. Certain unnamed companies may have acquired the technology, particularly the software for these things, through, how shall we say, non-traditional means, or yeah, through non-traditional means. And I think some of us know what we're talking about. Some of us may be kind of pondering what exactly I mean by that, but let's just say they didn't develop it themselves. So this is part of the reason why some of the lower end units are relatively cheap for everything they're able to do. Certain companies that we're talking about produce really good quality stuff, but they also don't necessarily um, as I found out recently, follow everybody's copyright and patent. So that can be an issue too. So if you're buying a cheap one, they're very good. They have a lot of capabilities, but um, there is this controversy around them. Also, I don't think I'm unique in the club. I know I've talked to other people and saying that some of us feel this kind of technology is a little bit cheating, even if it's legitimately developed. So you're never really going to learn the night sky or the hobby if the little robot does everything except for wheeling you out at night. So if you're trying to learn, the night sky, seeing objects for yourself, a finder scope, et cetera, this is not going to teach you much. It may teach you a little bit. You may learn the names of the constellations. You're going to see a lot of pretty pictures. You may figure out where in the heck in the sky it's oriented, although it can, with especially the ZWO that in the dark with the black one, it can be hard to figure that out. I was a little bit confused as to which way it was pointed to. You hear the buzz and the beep, and it kind of does its thing. But this, if you're really learning, basic astronomy in a deep way, this is probably not the best scope. I would still think a knob or a little refractor would be a better way to get started. But some of us, including some of us who feel that way, are also still buying. It may be a little bit hypocritical, but they are pretty cool, and I think they're able to do a lot more than some people expect. So, is it the future of astronomy or amateur astronomy? In the short term, no. I think for new users, it is. For a lot of people, for high-end users wanting top-notch imagery, or the experience of looking through a telescope, which you can't do with any of these. You can put together a much better rig with as much money, or in some cases, less money than the more expensive units. For the cheap ones, you're going to be challenged to find a Dob that's of good quality for less than a S30. But it is doesn't it is still I lost my train of thought. But in any case, long term, um, these are very popular right now, and I think that they're mostly meant for new users. As I said, a lot of us are using them for other things, but it is only a matter of time before units with excellent optics, large aperture, and especially large format, high density chips begin to come out. At least that's my opinion. I could be wrong about that. Maybe in 10 years, we're still looking at 50 millimeter lenses or at most 6 inches. But I tend to think that once the developers realize that this is really technology that's ready to take off, it will take off. And so, yes, for the high end users, it's not there yet. But given how technology curves work, I don't think it's going to be that long until really good quality, top-notch units that can keep up with the best of what we have in bits and parts get there. That said, also automated processing will get better and better. It may never keep up with what we can do ourselves, but again, if you have the option of just clicking a button versus spending 6 weeks building up and creating an image, I don't know if we'll ever get to that point, but it's always a thought. But still, some of us old guard are going to want to mix and match our equipment to our specific needs. For example, I have yet to want to see one that's really, really good at planetary imaging. Maybe that little 6 inch, but I tend to doubt it is meant for wide field, pretty pictures of nebulas and stuff. We can still do that with by mixing, matching our own images to make our own rigs. So I don't think that's going to necessarily go away anytime soon. Bottom line, a new generation of amateurs is likely to come into hobby with these things. That doesn't mean they're the only way people are going to come into this, but I think it's going to become more and more of a way that people come into this. Right now, it's just getting off the ground. I think that over the next 10, 15 years, it's going to be more and more typical for people to just grab these things, especially if they're fairly cheap, and just go with it on their backyards than unfortunately learning the details of the hobby. Or maybe they do both. I don't know. Many will stay with them as they become more and more advanced. Others, I think of us, are probably going to want to prefer a mix and match technique of better quality and more control. Maybe you don't want that particular combination of a telescope and imager that comes with that particular smart scope. You can get a lot more variety by taking, picking your own camera and picking your own telescope and picking your own mount than letting it all come as a single package. It's a little bit like the PC versus Mac. When I was a young person, the Macs tend to come, everything included in the PC was something you could build. I think there's going to be Mac people for a while, and I think there's going to be PC people for a while in these markets. I think for high-end astro imaging that does mix and match things, that is going to be a niche market, but it always has been. I mean, how many of us are really out there at night with high-end gear taking pictures? In this club, it's a lot of people, but we're talking tens of thousands in the country, not millions. Maybe it is millions. Maybe this is more than I imagine, but it's certainly not everybody. I think for everyone else in imaging who doesn't really want to fine tune things as much as okay, which is cool pictures, maybe good, really good, cool pictures, this may be the way to go. The last thing is, what about visual observing in all of this? What happens for those of us who actually like looking through a telescope? And I've heard various people have various feelings about this. Some people are like, oh, it's all just faint fuzzies. Who cares? Some people are very moved by looking through an image that they can see with their own eyes just through a piece of glass. And what I would say is right now, as of this moment, the balance of new scopes and users today, and especially in the past, have been visual users at first. Now, there are people who start with photography and then come into astrophotography. But for the hobbyists, it seems like a lot of the people I've talked to have started mostly doing this visually and then get into the astrophotography bug. There's more and more interest in the photography, though, because of what people see on the internet and people share on the internet and what people see in movies and pictures and things like that. The pictures have always been there. I mean, it's not like they're a new thing, but I think that the digital world has changed sort of what people's expectations are.
Did we lose Stephen?
Are you able to hear me? Because I just got the notice that my digital is my internet. Okay, there we go.
I can hear you now,
Um,
Steve.
Okay. I was just saying that some people are going to want to make the jump straight into astrophotography, and this allows them to do it. It used to be you needed either good, really good photographic skills or really good astronomy skills, or both to be able to pull off astrophotography. Now, not so much. This can do it very simply. Some will always want the experience of seeing the objects with their own eyes. That's why some of us came into this hobby. I don't think visual scopes are going to disappear completely. Some are going to get very bored very quickly with faint fuzzies. I know people who are very sophisticated astrophotographers who feel very strongly about, I don't want to look through a daub right now. Some of us think that's sacrilege. So it just depends on what your interest is. And I think that given the digitization of the human race, over time, the balance is going to shift in favor of photography at some point. But there's always going to be some of us who still want to look through telescopes. So is it the future? I think on balance, there's a good chance, but I think that it's going to always remain a diverse hobby with a lot of different people coming in with diverse interests, diverse tastes. A lot of people will be doing the photography. A lot of people will be starting with smart scopes, but I don't think it's ever going to be exclusively that. At least I hope not. I hope that big light buckets, like the one we just planted out at Timpa, which does not have a lot of photographic capabilities, but it's sure cool to look through, um, uh, remain at least out there and available for people who want the experience of actually looking at stars. That said, I think this stuff is really cool, but I don't think it's ever going to be the whole hobby. I think it'll be a major part of it, but I think there's going to be a lot of diversity in terms of options. So, that having been said, any comments or questions? I'll turn off my screen share if I can get this to work.
Yeah, one thing you didn't mention, Stephen, maybe not in detail anyway, is the firmware involved with many of these telescopes. They do not. I'm not sure about all of the manufacturers, but I know Unistellar for sure does frequent updates and improvements or additions to their firmware and software. I'm not sure about the other scopes though.
I will
And
say,
again,
also to add to that, the other major downside to these scopes is that if you're tethered to an iPhone or an iPad or a mobile device, that scope will only operate as long as the vendor supports an app on that device.
yeah,
So you can wind up, like most other scopes or cameras that may last you 20 years because they don't have that dependency. If they say, hey, we're no longer support iPad in 10 years, you're now down a scope. That
yeah,
scope will no longer work for
yeah.
you.
Cheap always comes with consequence, right? We can get a cell phone relatively inexpensively now, but how long is it going to last? And that's kind of why I class these things slightly different in slightly different classes. Unistellar, is my understanding, is the one that started this. Most of it is in-house of their own propriety, and they probably take this very seriously. I don't want to say that other companies don't. It's a different, slightly different product. And I don't want to say too much because I think I don't want to get anybody in trouble, but it's the kind of thing where there's a lot of different options. As with anything out there, and especially anything electronic, do your homework first and find out what is the best match with you. Bernie, I've looked through your Unistellar; it's gorgeous. It's a really nice scope. Nelsie, I've looked through your ZWO. It's a nice scope too. It just depends on what you want to do with it. But I think that has to be said is this is more digital technology than it is astronomical. So yeah, when they stop supporting it, the scope is dead. So that's different from a Dob where you can use it for 30 years if you want to, and as long as you keep it clean and maintained, it'll probably be okay.
Unless you hold on to a tablet that you don't upgrade.
Yeah, yeah, yeah.
Star
And
also
even,
does regular updates. And with the last one, they added a mosaic feature. So I've been playing with that. It's a really nice feature. I can now take Andromeda, Rosette Nebula, things that are quite large.
yeah, in the chat, there's just nothing but several thanks, Stephen, for putting together and providing the information.
All right, cool. And I may come back to talk about more of these things when I learn how to actually use one. So thank you.
And with that, that's all we had on the schedule for tonight. As I had mentioned in December, one of the topics in February will be my part 2 on galaxy classification. I don't have anyone else on the schedule for an astronomer or another topic. I don't know if Stephen or Pete would want to volunteer for that. Um, but if not, so you'll at least have one known presentation to look forward to come February.
If you can't come up with anything else, well, that night I have to be somewhere else, so I probably can't do that. Actually, it's the previous week, but I might redo the planets that night if you can't find anything else.
I'll keep that in mind, Steve. Thanks. And with that, I will see everybody next month. Thanks for joining us.